There is a number attached to the Great Canal that carries water across California, and it is not the kind of number that makes headlines the way a wildfire or a flood does. It is a quieter kind of number, the sort that appears buried in engineering reports and budget documents, but it may nonetheless be one of the most consequential figures in the future of the American West. The number is $2 billion, the price tag on a massive effort to repair the aqueduct that moves water hundreds of miles from the wet northern part of the state to the thirsty farms and cities of the South. And attached to that $2 billion is another number, one that ought to give everyone who depends on that water pause. The fix, for all of its great expense and its engineering ambition, buys only about 11 years. 11 years before the same problem returns, before the ground shifts and settles again, before the canal that was just repaired at enormous expense begins once more to fail at doing the one thing it was built to do. This is the story of that repair, of why it is necessary, of why it buys only a decade or so of relief, and of the far harder question that looms behind it, which is what California does when those 11 years run out. To understand the problem, you first have to understand what the aqueduct is and why it matters so much. California is a state of profound geographic contradiction when it comes to water. Most of the rain and snow falls in the northern part of the state and in the mountains, while most of the people and much of the most productive farmland lie in the drier central and southern regions. To bridge that gap, California built one of the most ambitious water delivery systems ever constructed, a network of canals and pumps and reservoirs that captures water in the north and moves it south across enormous distances. The centerpiece of that system is the Great Aqueduct, a concrete-lined canal that stretches for hundreds of miles down the spine of the state, carrying the water that irrigates one of the most productive agricultural regions on Earth and helps sustain the sprawling cities of Southern California. It is, in a very real sense, one of the arteries that keeps the state alive, and the food it helps grow reaches tables far beyond California's borders. The trouble is that this vital artery is sinking. And the reason it is sinking gets to the heart of a deeper crisis. In the agricultural regions the aqueduct passes through, farmers have for decades pumped enormous quantities of groundwater out of the ground to irrigate their crops, especially in dry years when the surface water delivered by the aqueduct is not enough. When you pump water out of the ground faster than it can be replenished, the land itself begins to sink, a phenomenon known as subsidence. The soil compacts as the water is removed from between its grains, and the surface of the ground drops, sometimes by inches a year, sometimes by feet over the course of decades. In parts of California's Central Valley, the land has sunk by staggering amounts over the years, some areas dropping by tens of feet since the practice of heavy groundwater pumping began. And this sinking ground has a devastating effect on the aqueduct that runs through it. The problem is that a canal works by gravity. Water flows downhill, and the aqueduct was engineered with a precise, gentle slope so that water would move steadily from the north to the south along its length. But when the ground beneath a section of the canal sinks, that carefully engineered slope is disrupted. The canal sags in the places where the land has dropped, creating low spots where the water cannot flow as it should, where it backs up and pools instead of moving smoothly downstream. The result is that the canal loses capacity. It can no longer carry as much water as it was designed to carry, because the sagging sections act like kinks in a hose, restricting the flow. Some stretches of the Great Aqueduct have lost a significant fraction of their original carrying capacity because of this sinking, meaning that even when there is water available to move, the canal simply cannot deliver as much of it as it once could. A system built to carry a certain amount of water now carries substantially less, and that lost capacity translates directly into water that does not reach the farms and cities that depend on it. This is what the $2 billion is meant to address. The repair effort involves rebuilding the sagging sections of the canal, raising the walls, restoring the slope, and returning the aqueduct to something closer to its original capacity so that it can once again carry the volumes of water it was designed to move. It is an enormous undertaking, a major feat of engineering and expense. And when it is complete, it will genuinely restore a great deal of lost capacity to the system. Water that could not get through the sagging sections will flow again, and the farms and cities that had seen their deliveries constrained will see that constraint eased. In that sense, the fix is real and valuable. It solves a genuine problem and restores a genuine capability. But here is the crucial catch, the reason that 11-year figure hangs over the whole project like a shadow. The repair fixes the symptom, but it does not fix the disease. The canal sank because the land beneath it sank, and the land sank because of groundwater pumping, and the groundwater pumping has not stopped. As long as farmers continue to pump water out of the ground faster than it is replenished, the land will continue to sink, and the newly repaired canal will begin to sag all over again. The $2 billion raises the canal back up and restores its slope, but it does nothing to address the underlying cause of the sinking. And so the engineers who study these things can estimate, based on the rate at which the land is subsiding, how long the repair will last before the problem returns. That estimate is where the 11-year figure comes from. In roughly 11 years, give or take, the continued sinking of the land is expected to undo enough of the repair that the canal will once again be losing significant capacity. And California will be facing the same problem it just spent $2 billion to solve. This is the uncomfortable truth at the center of the whole enterprise. The fix is not a permanent solution, but a temporary reprieve, a way of buying time. It is like repairing the cracks in a wall that keeps cracking because the foundation is unstable. You can patch the cracks, and the wall will look whole again for a while, but until you fix the foundation, the cracks will keep coming back. The foundation problem here is the unsustainable use of groundwater, and it is a problem that California has been grappling with for a very long time without fully solving. The state has taken steps to address it, passing laws intended to bring groundwater pumping into a sustainable balance over the coming decades, requiring local agencies to develop plans to stop the overdraft and stabilize the aquifers. But bringing groundwater use into balance is enormously difficult because it means asking farmers to pump less, which in many cases means growing less, which strikes at the economic heart of some of the most productive agricultural communities in the country. And this is where the 11-year clock becomes something more than an engineering estimate. It becomes a deadline, a countdown to a decision that California cannot avoid forever. The $2 billion repair buys roughly 11 years. And the question is what the state does with those 11 years. There are, broadly, two possibilities. In the first, California uses the time wisely, accelerating the transition to sustainable groundwater use, so that by the time the 11 years are up, the land has stopped sinking or slowed its sinking dramatically, and the repaired canal can last far longer than it otherwise would. In this version of the future, the $2 billion is a bridge, a way of keeping the water flowing while the deeper problem is solved, and the investment pays off because the underlying cause is addressed before the reprieve expires. This is the hopeful scenario, the one in which the repair is part of a larger, coherent strategy to put California's water use on a sustainable footing. In the second possibility, California does not solve the underlying problem in time. The groundwater pumping continues at unsustainable levels, whether because the transition to sustainability proves too economically painful, or because the political will falters, or simply because the problem is so large and so entrenched that 11 years is not enough to solve it. In this version of the future, the 11 years pass, the land keeps sinking, the canal sags again, and California finds itself right back where it started, facing another enormous repair bill to fix a canal that will only sink again. This is the treadmill scenario, in which the state spends billions of dollars every decade or so to keep repairing a canal that keeps failing. Forever chasing a problem it never actually solves, pouring money into symptoms while the disease goes untreated. It is an expensive and demoralizing prospect, and it is the future that looms if the 11 years are squandered. To appreciate just how large the sums involved really are, it helps to place the $2 billion in context, because the figure is not the whole story. $2 billion restores the sagging sections that are the most urgent, but the aqueduct is only one of several major conveyance systems in California that have suffered from the same sinking ground. There are other canals, other stretches of infrastructure that have lost capacity to subsidence, and the total cost of restoring all of them runs to many billions of dollars more. When you add up the full scope of the damage that groundwater overdraft has done to California's water infrastructure, the price of simply keeping the existing system working climbs to a staggering figure. And that is before considering the cost of the deeper fixes that would actually address the sinking. The $2 billion for the Great Aqueduct, in other words, is a single-line item in a much larger bill that the state is only beginning to add up, and every year that the overdraft continues, that bill grows. This is the hidden cost of unsustainable groundwater use, a cost that does not appear in the price of the crops or the water, but that shows up eventually in the form of enormous repair bills for the infrastructure that the sinking destroys. There is a further irony worth naming, which is that the sinking ground damages far more than the aqueduct alone. As the land subsides, it wrecks not only canals, but wells, roads, bridges, pipelines, and the casings of the very wells that farmers rely on to pump the groundwater in the first place. When the ground compacts, it can crush and deform well casings, rendering wells useless and forcing the drilling of new ones at great expense. It can crack roads and buckle bridges and rupture pipelines, imposing costs on communities far removed from the farms doing the pumping. The subsidence, in other words, is not a localized problem confined to the canal, but a slow-motion catastrophe unfolding across the entire landscape, damaging the built environment in countless ways, and the aqueduct repair addresses only one piece of it. The $2 billion is the visible tip of a much larger and mostly invisible toll that the sinking is exacting across the region. A toll measured not only in dollars, but in the gradual degradation of the infrastructure that an entire civilization in the desert depends upon. The reason this matters so much beyond the specific question of one canal is that it is a perfect illustration of the larger predicament facing water in the American West. Across the region, there is a persistent temptation to solve water problems with engineering, to build our way out of scarcity with bigger canals and deeper wells and more elaborate infrastructure, without confronting the fundamental imbalance between how much water there is and how much we want to use. The aqueduct repair is a case study in the limits of that approach. You can engineer a fix for the sagging canal, and it will work, but only for a while, because the engineering does not address the behavior that caused the problem. The canal sinks because we pump too much groundwater, and no amount of concrete and steel will change that underlying fact. Sooner or later, the West has to reckon not just with the symptoms of its water crisis, but with the causes, and the 11-year clock on the aqueduct repair is a reminder of how those two things are connected. It is worth dwelling on why groundwater overdraft is so hard to stop, because it explains why the 11 years may not be enough. For a farmer in a dry region, groundwater is a lifeline, the water that keeps the crops alive when the surface deliveries fall short. In a good year, when the aqueduct is delivering plenty of water, the pressure on the groundwater eases. But in a dry year, when the surface water is scarce, farmers turn to their wells, pumping hard to make up the difference. And it is precisely in those dry years that the overdraft accelerates and the land sinks fastest. As the climate warms and dry years become more frequent and more severe, the pressure to pump groundwater intensifies rather than easing. This creates a vicious dynamic in which the very conditions that make surface water scarce also drive the groundwater pumping that sinks the canal that delivers the surface water. The crisis feeds on itself, and breaking that cycle requires either finding new sources of water to replace the groundwater or accepting that less land can be farmed, and neither of those is easy or painless. It is also worth understanding how the 11-year estimate is arrived at, because it is not an arbitrary guess, but a projection grounded in careful measurement. Engineers and scientists track the rate of subsidence along the canal using a range of tools, from precise ground surveys to satellite measurements that can detect the sinking of the land to within fractions of an inch across vast areas. By measuring how fast the ground is dropping in the sections most prone to sinking, and by knowing how much the repair raises the canal and restores its slope, they can calculate how long it will take for the continued subsidence to eat away enough of the restored capacity that the canal is once again significantly impaired. The 11-year figure is the output of that calculation, an estimate of the useful life of the repair given the rate at which the ground is expected to keep sinking. It is important to recognize that this estimate depends on assumptions about future pumping, and that the number could prove optimistic or pessimistic depending on what actually happens. If dry years cluster together and pumping intensifies, the sinking could accelerate and the repair could fail sooner. If wet years allow the aquifers to recover and the pumping to ease, the repair could last longer. The 11 years is a central estimate, not a guarantee, and the range of possible outcomes around it underscores how much depends on choices that have not yet been made. There are efforts underway to break the cycle, and they are worth understanding because they represent the real work that has to happen in the 11 years. One approach is groundwater recharge, the practice of deliberately capturing water in wet years, when rivers are running high and there is water to spare, and using it to replenish the depleted aquifers. Spreading it across fields and letting it soak into the ground to refill the underground reserves. Done at a large enough scale, recharge could help stabilize the aquifers and slow or stop the sinking, addressing the root cause of the canal's troubles. Another approach is the difficult work of fallowing, of taking some farmland out of production, particularly the land that is most dependent on unsustainable groundwater, and finding ways to compensate the farmers and communities affected so that the economic blow is cushioned. And there is the ongoing push toward greater efficiency, toward crops and irrigation methods that produce more value with less water. All of these are pieces of the puzzle, and all of them have to advance significantly within the window the repair provides if the 11 years are to be used well. The honest assessment is that it remains uncertain whether California will manage it. The laws are in place, the plans are being written, the recharge projects are being built, and there is real momentum towards sustainability. But the scale of the overdraft is enormous. The economic stakes for agricultural communities are high, and the timeline for achieving sustainability under the state's own framework stretches out over many years, in some places longer than the 11 years the canal repair buys. There is a real risk that the sinking will continue faster than the transition can keep up with, and that the repaired canal will begin to sag again before the underlying problem is solved. If that happens, the $2 billion will have bought time that was not fully used, and the state will face the treadmill, the prospect of repeating the repair again and again while the deeper crisis persists. None of this means the repair is a mistake. Buying 11 years is genuinely valuable, especially if those years are used to solve the underlying problem. And even the harshest critic of the engineering-first approach would concede that the water has to keep flowing in the meantime. Farms cannot simply be shut down overnight. Cities cannot go without water while a decades-long transition plays out. And the canal has to keep working during the transition to sustainability. The repair keeps the water moving, and that is not nothing. The danger lies not in doing the repair, but in mistaking it for a solution, in treating the restored capacity as if it has fixed the problem, when in fact it has only postponed it. The 11-year figure is a warning against that complacency, a reminder that the clock is ticking even as the water flows once again through the restored canal. So the question posed by the title, the question of what comes after the 11 years, is really the central question of California water, and of Western water more broadly. It is the question of whether the region can move beyond the era of engineering its way around scarcity and into an era of actually living within its means, of using no more water than the land and the rivers can sustainably provide. The aqueduct repair is a bridge to that future, but a bridge is only useful if there is something on the other side. If the 11 years are spent building towards sustainability rather than simply postponing the reckoning. If California uses the time to stabilize its aquifers, to recharge its groundwater, to bring its pumping into balance, then the $2 billion will have been well spent, a down payment on a sustainable future. If it does not, then the 11 years will pass, the canal will sink again, and the state will find itself writing the same enormous check to solve the same unsolved problem, having learned nothing except how expensive it is to keep ignoring the foundation while patching the cracks. The land beneath the Great Canal will keep sinking for as long as the water beneath it keeps being pumped away faster than it returns. That is the physical reality that no amount of concrete can change. The repair raises the canal back up, but gravity and geology will pull it down again unless the pumping slows. 11 years is the time the engineers estimate before that happens, before the sagging returns and the capacity is lost once more. It is not a long time, not for a problem this large and this deeply rooted in the economy and habits of an entire region. And so the 11-year clock that starts ticking the moment the repair is finished is really a clock counting down to a choice California has been putting off for generations. The choice between continuing to engineer around its water problem and finally confronting the fact that it uses more water than it has. The $2 billion buys the time to make that choice. What it cannot buy is the wisdom or the will to make it. And that, in the end, is the thing that will determine what happens when the 11 years are gone. It is tempting to see the whole situation as a failure, a story of mismanagement and short-sightedness, and there is certainly an element of that. But it is also worth acknowledging the genuine difficulty of the choices involved, because the people making them are not fools or villains. The farmers who pump the groundwater are growing the food that feeds millions. Operating within an economic system that has long treated groundwater as a resource to be used, and they face real ruin if the water is taken away too quickly. The officials who approve the repair are keeping water flowing to communities that cannot survive without it, making a defensible decision to preserve a vital artery while the larger problem is worked out. The tragedy, if it is one, is a tragedy of the commons, the familiar and painful situation in which each individual acting reasonably in their own interest produces a collective outcome that harms everyone, as the shared aquifer is drawn down by countless separate decisions that each make sense on their own. Solving that kind of problem requires collective action, coordination, and often sacrifice, and those are among the hardest things for any society to achieve, which is precisely why the 11-year clock is such a daunting challenge and not merely a technical deadline. The water will keep flowing for now, down the length of the restored canal, to the farms and the cities that have depended on it for generations. The fields will be green, the taps will run, and for a while it will be possible to believe that the problem has been solved. But underneath the fields, the aquifers will keep dropping if the pumping continues, and underneath the canal, the ground will keep compacting, and the slow, patient physics of subsidence will keep working to undo the expensive repair. 11 years will pass more quickly than anyone expects, and when they do, California will meet again the question it faces now, only with less time and less money, and a canal that is sunk a little further. The best hope is that the state treats this repair not as an ending, but as a beginning, a window of borrowed time in which to do the hard and unglamorous work of bringing its water use back into balance, so that when the 11 years are up, the answer to the question of what comes next is not another $2 billion repair, but a canal that finally sits on ground that has stopped sinking, carrying its water above land that has at last